Hey Algebra Crew, here we are, your last video of Trimester 2. And it's a little bit of a review just like we did yesterday, but let's see what topic we're up to today. Let's read number 1. Kathy plans to purchase a car that depreciates or loses value at a rate of 14% per year. The initial cost was $21,000. Which equation represents the value after 3 years? Now, what does this sound like to you guys? They're asking about an equation. So what kind of equations did we learn about this year? So far, we've learned about either linear or exponential. Remember, linear was adding or subtracting by the same value, and exponential was multiplying by the same value. So what's the key here? The key here is this 14%. Remember, percents look like decimals. So if I took 14%, I could turn this into 0.14%. And it says rate. So I'm going to go with exponential on this one. And the formula for exponential was y equals b. All right, these are the two equations, guys, that we have for exponential. Y equals p, 1 plus r, or 1 minus r to the t, or y equals ab to the x. Remember, here we have a percent. So right off the bat, we know that these first two values here, the p and the a, are our y-intercept, which is our initial value. Our initial value is 21,000. They all have 21,000, not helping us. Let's move on. We know that t is time, and time is our exponent. So 3 years should be in our exponent. I see 3 here, 3 here, 3 here, but I don't see it here. So we're going to eliminate choice number 4 because time is not in the exponent. It actually has no exponent at all. So now we're stuck between 0.14, 0.86, 1.14. So it says depreciate. So depreciate means to subtract. So I'm going to go ahead here and I'm going to use this first equation. So we have y equals 21,000. Then 1, depreciate means to lose. Lose means subtract. And r needs to be the decimal, which is why I converted it before, to the t3. So right away, we could also eliminate number 3, because number 3 was an increase. So we're eliminating 3 because the multiplier, which is this middle value here, this is the multiplier. The multiplier increased instead of decreasing. And then from there, you guys can figure out the right choice, but eliminating 2 gives us a much better shot. Let's move it down here. The New York Volleyball Association invited 64 teams to compete in the tournament. After each round, half of the teams were eliminated. Which equation represents the number of teams that remained in the tournament after our rounds? So let's set this one up differently. This again, we're eliminating half each round. So each round gets multiplied by a half. That kind of sounds like exponential to me again. And we're talking about half-life. That's what gave it away. So let's find what's P, what's R, what's T to help us eliminate two choices. So P was our starting value, our principal value, which was 64 teams. My rate is decreasing by half. So if I'm decreasing by a half, 1/2 is 0.5. Remember, we rewrite it like this, 1 minus 0.5. And our time, and it says the teams that remained after R rounds. Our time is just R for rounds. Okay, so let's see. What could we eliminate? All of them have 64 as their principal value, so that's no help. Let's look at the multiplier. Number 1 is interesting. The R value is in the multiplier position when we said that rounds was supposed to be our time. And 0.5 has nothing to do with time. So we're going to eliminate number 1 because 0.5 is the rate, not the time. Okay? Next. What else can we eliminate? Well, the problem says eliminating half the teams. So how could possibly our multiplier go up? How could we possibly get more teams if we're eliminating them? So 3 I don't like either. Because, again, the multiplier is increasing, not decreasing. All right, guys. So again, from there, I want you to go ahead and choose between choice 2 and choice 4. And we're going to move on to the last question. Which equation models exponential decay? Well, it told us right there in the question what topic it is. The topic is exponential decay. Okay, and remember, in order to determine if it's exponential decay, we need a multiplier that is less than 1. So, and remember our multiplier, if we have y equals a, b, x, b is the multiplier. So let's look at all the b values. Let's go ahead and highlight some of them for us. So we'll have -2 here. We have 2 here. We have 0.2 here. And 1.2 here. Now, when we looked at exponential equations in class, we never, ever seen a negative multiplier. We seen a negative y-intercept, but not a negative multiplier. So A, I'm going to eliminate because we're going to eliminate A because the multiplier is negative. And let's go across. We have B, C, and D. Well, if the multiplier needs to be less than 1, and B has a multiplier of 2, that doesn't make sense. So we're eliminating B because the multiplier is greater than 1. And again, I want you guys to determine between C and D which one is the correct choice. If you have any questions about trimester review or the exams, please jot them in at the end and we'll hit them in class.